Welcome, welcome, welcome to this edition of the SAS Viya Release Highlight Show. I'm Anna Brown, your host, and boy, we have a great show today, packed with release updates from 2021.1.3. That's the SAS Viya release we're talking about. What are we going to cover? Well, we'll talk about a custom step designer to better manage your flows. We'll take a look at a new text mining node to pull in that unstructured data into your predictive models. And tell me, anybody use Microsoft Teams out there? Anyone? Tell me in the live chat on YouTube or on the discussion on LinkedIn. And then also tell me if this gets you excited. We're now integrating chatbots into Teams. So that's SAS Conversation Designer, integration into Microsoft Teams. We'll also take a look at some SAS deployment options in a container that can now run on new cloud platforms like Azure, GCP, and AWS. Then we'll get a nice long look with my friend Steve Sperano, Principal Product Manager, and we'll look at a real-time object detection capabilities in SAS Event Stream Processing. So you won't want to miss that. So tell us what you think. Does any of this interest you? We want to hear your comments and questions in the discussion. So we can't wait to get you involved here today. Without further ado, I want to introduce the rundown.
In this release, an exciting new introduction to the Custom Step Designer, where you can drag and drop components to front-end your code with prompts. As well, you can create dependencies between prompts so that the prompts show up based on what kind of relationship they have to other controls. As well, you can upload and download your custom steps, make them favorites, rename them, copy them. And what if you've got a large flow that's difficult to view? Well, the new flow overview map allows you to navigate around in a flow and be able to go quickly to the part that you actually need to deal with. So a lot of exciting features in this new release.
In Model Studio, we have a few new features to highlight. First, we now include a text mining node in automatically generated pipelines when a text variable is designated, allowing information from unstructured data to be used for training predictive models. Within the text mining node, we've also added options for specifying start and stop lists to control which terms are kept or dropped during text parsing, and for synonym lists to create custom parent terms or to add terms grouped under a parent term. And now you can easily create a report for your project in PDF form. So it's really easy to export and share the insights from your modeling projects with others outside of the SAS environment.
Access the power of analytics anywhere. We now provide support for SAS chatbots within Microsoft Teams. Organizations have adopted new working patterns since last year and now use enterprise messaging software more often. I'm pretty sure many of you would be using Microsoft Teams more than you access your email. How productive you would be and how convenient it is to just join a meeting and while participating, easily obtain answers and insights from a SAS Conversation Designer chatbot. It makes for better collaboration with your colleagues since answers are more readily available and you don't have to spend time in offline clarification. If you use Microsoft Teams, a designer within your organization can help configure the bot to be accessible on Teams as well as on Azure. All that's needed are the parameters necessary to populate a manifest file, which is configured within the App Studio application inside Microsoft Teams. We have worked hard to make the process a zero-code process and have automated many of the steps necessary to populate this manifest file. Using the bots channel in Azure, if you like, you can also provide your bot additional security through authentication, making full use of the capabilities that Azure has to offer. So there you go. You now have the power to access analytics anywhere. Already enabled on customer engagement platforms like LivePerson, on web applications, and now on Microsoft Teams running on your computer.
It's all about publishing destinations with SAS Model Manager. We have 2 new publishing destinations. Let's talk about the first, SAS Container Runtime. You heard it, it's a container that supports SAS models. This is new for us. This is a way for us to be able to take all your favorite SAS models, whether created in Viya or created in Enterprise Miner or other 9.4 technologies, where they're registered into SAS Model Manager. We can easily go and create a container. What's better, these containers can run anywhere. So they can run in your favorite registry, whether it's Azure, AWS, GCP, private Docker, you name it, you have lots of flexibility. The second new publishing destination is Azure Machine Learning. Now you'll remember several months ago we created a publishing destination for Python created models. Now we've updated it to support SAS models. You can see we still dynamically discover the workspace associated with your subscription ID. Now it's easy to be able to take those SAS created models and be able to register them directly into Azure Machine Learning. So let me go over into Azure so I can show you what happens. In my Azure workspace, you can see that those models, inclusive of the SAS models and open source Python model, have all been registered into Azure Machine Learning. We pass all the necessary artifacts over to Azure Machine Learning for them to create the container. What's great is now you have the ability to take these containers and use them in downstream applications like Power Apps or any of the Microsoft applications. Again, we do publishing validation just to make sure all the score code works best. My favorite part, we've created an easy button to go ahead and create a long-standing endpoint using Azure AKS. So many great things with SAS Model Manager. Thanks so much for watching.
Great updates, team. Thank you. Amy, I love that overview map for larger flows in SAS Studio. And I don't know if you caught it, but there is a handy dandy how-to article on that text mining node in SAS Model Studio. And you'll be found in the description underneath the SAS users YouTube channel where this video is streaming right now. So check that out for how to employ that text mining node. All right, now we get to talk with Principal Product Manager Steve Sperano about some real-time object detection capabilities in SAS Event Stream Processing. Steve, welcome to the show. Tell us, what does this really mean and how does that work?
Hey, Anna, thanks for having me. I'm really excited to be here and talk about these new features. Really what this comes down to for real-time object detection is our new support for ONNX model format. And ONNX is really just an acronym, and it stands for Open Neural Network Exchange. What that really means is that's a format of models that are produced by other third-party machine learning frameworks to make it easy to interchange, like the X means exchange, interchange those models from one environment where I'm training the models and making them available for inferencing or deployment in another environment. That really provides a couple of key benefits in the SAS Event Stream Processing world. One, we're now providing native format support for those ONNX models. That means you don't have to convert them to another format in order to use them, so you preserve everything about what you originally trained. The second is in ESP Studio, which is our design time environment, we're making it easy to grab that ONNX model you've created, something like PyTorch or TensorFlow or Caffe, and import it to an ESP project. And then, of course, you've got to put it to work. So we're making it easy to deploy that ONNX model into a runtime environment. And what we've done essentially is we've abstracted away a lot of that complexity for the end user because we've integrated with a technology called ONNX Runtime. And as the name implies, it's about making those ONNX models run. And this was open sourced by Microsoft, one of our key partners. So we've integrated that into the platform with ESP to facilitate deploying to what are called execution providers. That really just means it's easy to deploy those models you trained to NVIDIA GPUs for acceleration to make them score and perform inferencing faster, or to Intel GPUs and CPUs for accelerated inferencing. So we've connected all of those dots together for you and now provide that natively out of the box with ESP.
Excellent. And so what are
Yeah.
you seeing in terms of some prominent use cases? How are some applications there in the industry for
Yeah.
this technology?
These are really object detection or computer vision examples and use cases we're seeing. That's been around a while. Interesting ones where we're starting to see interest from our customers and where they're deploying it in the age of COVID. A lot of manufacturers and some of our industrial customers want to know, are their workers safe? Are they spending too much time together that is too close together? We can identify these different workers, how long they've spent next to each other, and be able to identify those. In manufacturing, it's used in quality. So how can I identify parts that aren't meeting the quality standards of our customers and do things like inspect with computer vision welds as part of robots, or looking inside of different factories and identifying, are workers acting in a safe manner? If they're performing a duty, are they wearing the right protective equipment? All of this then can be used to detect those situations, protect workers, and improve quality, which increases profits for our customers. All of that is driving better outcomes for those users.
Excellent. So I think you're going to show us a demo here. Tell us a little bit about
Yeah.
what that scenario will look like in the demo we're about to
Yep.
see.
Yeah, in the demo I've got lined up, what we're going to do is we're going to look at essentially a generalized application of object detection and classification. And we can now apply this since it's a general application, to any one of those use cases, depending on the model that you've created. So we're giving those data scientists a lot of choice and flexibility to bring that into this environment and then apply it to whatever problem they have at hand.
Excellent. All right, well, let's take a look.
Great. Here we are inside of SAS Event Stream Processing Studio. And like we talked about in the beginning, is what we want to show now is in this design time environment, how we're going to integrate those ONNX models into a streaming analytics project. And it's actually pretty simple. One of the things we're not going to go into is how to build an ONNX model. And like we said in the beginning, these ONNX models really come from both SAS, because SAS can create ONNX format models, but they can also come from these third-party machine learning frameworks like TensorFlow or PyTorch or Keras. So here in ESP Studio, I'm going to open up a pre-built ONNX project. And one of the things we can see here on the left is all the different capabilities we have from our palette on the left. And we'll show how we're taking advantage of some of these inside of this ESP project you see in the center. The best place to start is at the beginning, which is known as the source window. And what we're bringing in here is through a connector, and I can see it over on the left-hand side, using essentially a file socket connector, a way to inject or ingest images into this project. Because one thing we're doing as part of this project is using this ONNX model for inferencing to be able to do computer vision examples. And we'll talk about a little bit later some other use cases we have, but the goal here is to use the ONNX model to process or score these images as they arrive and be able to detect different objects within those images. So are there people in the image? Are there cars in the image? And we'll even see some cases where are we identifying other types of objects like tables or chairs or even animals. We're just using some sample images in this case. The second step in this process is some pre-processing we have to do on those images to prepare them before they get scored or before the inferencing occurs using that ONNX model. And that pre-processing is done, if I go up to the project level, using some Python code that's part of this. And inside of what we call a microanalytics service module are some pre-processing code for this image itself. And really, we're using some Python. And we have examples of this that you can also access on your own. But this Python code, what it's doing is it's resizing some of the images when they come in so they're consistent, but it's also preparing what's known as tensors. And tensors are just n-dimensional arrays that the ONNX model needs to perform its inferencing and its scoring. And that scoring really happens in this next step once that pre-processing is done. The way the ONNX model is actually injected into this model is using something called a reader window, a model reader window. And it's as simple as specifying where that ONNX model, in this case, a TinyYOLO V2 model, where it's located. And in this case, because we're running in the cloud using Kubernetes, this is specified as part of a persistent volume, basically a path up in one of the pods so that the ESP project can access it. The other key part is we're supporting execution providers. And execution providers are really those hardware accelerators. In this case, in this demo, we'll be using a CPU to do the scoring. But we can also support CUDA and TensorRT. Those are essentially hardware acceleration libraries for NVIDIA GPUs. This means that without having to recode that model, that ONNX model, we can support deploying these out to those different hardware platforms. Again, in this case, for this demo, we'll be using a CPU, but in the future, we'll also be supporting OpenVINO, which are the Intel-based GPUs for acceleration, but also Intel-based CPUs for acceleration. That reader window injects that model, because it knows where it is, into the score window. Now that pre-processed set of images can flow through and be scored, and we can detect objects. There's another step associated with post-processing, using the same Python code, just a different function as part of it, to be able to take the output from the ONNX model, those tensors that I talked about, which are, again, just arrays of information, parse that apart to be able to identify the boxes or the objects that have been identified and the labels associated with it. Essentially, that means, have I identified a person, an animal, a dog or a cat, a table, a bus, a car, whatever that may be. This pre-processing and post-processing work together along with the ONNX model to be able to deliver the results. The following steps take those labels that we have and now identify from the labels output by this post-process step and identify exactly how many of those individual objects there are, and then the last step is just counting those. We're essentially using what we have as an aggregate window to count up how many buses, cars, or whatever have been identified in the frame or inside of the images that are passed. Now, that's an overview of the design, but one thing we want to be able to do before we push any of this into production is actually test this. So in ESP Studio, we have the ability to test, and I'll go ahead and enable logging for this test, and we can monitor different aspects of that process. So you saw the data step, the pre-process, the scoring step, and when I hit run, it's going to use our underlying Kubernetes operator framework, which will use these settings at deployment time. And again, this is a test deployment, not to production, but we're going to use these settings to determine exactly how much resources we tell Kubernetes to allocate for this test. So it's a combination of using the ONNX open source models and this brand new operator from Kubernetes in the cloud. This means that our users don't have to worry about any of this administration. Just pass those settings at deployment time and Kubernetes takes over using custom resource definitions. You see the logs starting to stream through on the bottom. And what we'll start to see in a moment here is the actual connectors start to kick off. That means I'm connecting to that test set of information in my first step in the process. There it is, the connector started. And we'll start to see the actual data flow. And what we're starting to see are the different images. Now, ESP runs much faster than this. And for this demo, what I've done is actually put in a throttling mechanism so we can slow it down and see it before it completes immediately. But those different windows that I've checked over here are available for me to look at. I can do things like look at what's the output of that parse label step, and you can see it's starting to identify people, cars, buses, and so forth. And I can look at the count object step. Of course, this is telling me what's the total count for each one of those objects. This is one way to look at some of this information, but again, it's a design test mode. So let me go ahead and stop this particular test at this point.
This is a test mode, but what happens or what does it look like when you actually push this into production in a production environment?
Yeah, that's a good question. That was the test mode, so I can essentially validate, am I getting the results I expected? And if I do, we have an offering called SAS Event Stream Manager, which is part of the ESP suite, which supports deploying those ONNX models as part of that project I just tested out to a production environment. And where we typically deploy to, and that could be deployment out to the edge or to the cloud. Sometimes we have these imaging systems like cameras on the edge, but also in the cloud, we want to bring these images back and score them there. So I've set up a deployment, which is up in Azure or an instance of Azure on a cluster or a Kubernetes-based environment. I can open this deployment, and currently there's nothing running there, but by simply pressing this start button, I can select the version of that project using ONNX, the same ONNX project, And I can use those similar settings here to determine exactly what I want to deploy into the cloud. Specifically, these settings help me determine, for Kubernetes' sake, when to spin up new pods, replicate that project, and start to distribute or load balance these different events and the load across those different instances. So I can tell it if you reach a certain memory limit or CPU utilization. If you hit those limits, then I want you to create new replicas. Right now, I'm just using one because I'm not using load balancing. But load balancing is also available. And really what that means is if I create new pods where these replicas are running, so I go from 1 pod to 5, it's intelligent enough to spread the load across that. We can get into that in a whole nother session, but that load balancing is available as part of this as well and gives you the flexibility to determine which input window to be able to load balance. In this case, our project just has one. So if I turn that off and click OK here, it's going to use these settings and deploy this out to that cluster. So you can see how quick that was.
Yeah.
I see here I've got this project running, and what I'm running on now is this particular pod. So one pod has been started. You saw I specified start with a single replica and go up to just one because of load balancing. You can see some details about it and the log information. This is good because as we're debugging this, say in production environment, if there's a problem, I can see information about various logs, like the operator, which is the Kubernetes operator. Were there problems with creating new instances? And what were those? Were they fatal errors or not? I can even look at the console message. What you see here is a lot of the information related to the images that are being passed in to this particular project. But I can also now jump over, and while this is running in a production environment, I can also look at what this looks like visually. You saw in the test mode, I had a table seeing the different images streaming through. I have the ability to also look at this environment in a streaming environment. Now we've jumped over to the SAS Event Stream Processing Stream Viewer, which is looking at the results associated with the project that's now running in production. Since I've just deployed that, I can go ahead and hit refresh and get the latest information. As you can see here, we're starting to see on the upper left the count of objects that were identified using that ONNX model. So I've seen tables and people and boats and various animals as well. And over on the right is another representation. So these are essentially visualizations that are available to us inside of the Stream Viewer. On the lower left side, you can see a representation of the process itself, the actual project I designed back in Studio, and I can see the number of events being processed at each step. This gives you a little insight into how the project's running. In this case, the ONNX model at that score step and any post-processing that's happening after the fact. If the CPU performance starts to degrade, we would start to see some of the alerts show up here on performance and start to see that here. So,
and can you expand each of these quadrants, Steve, to get more information, like that model diagram, for instance? Does it let you make that bigger?
Yeah, you actually have the ability to zoom in and zoom out on this,
Right.
and then scroll around as part of this as well. These are just the ones I've selected here. If I wanted to add additional information, I simply select the model viewer, select the window that I want, and it adds a new one to the actual tablet itself here as my dashboard. So now I have the ability to create graphics based on this by simply clicking here and creating a new chart. I can go ahead and close this one to put it back. So if I return back to my managed streaming environment or the SAS Event Stream Manager, the last thing I'll do is go ahead and shut down this project, which is running. For that deployment, that cloud deployment on Azure as a Kubernetes cluster, you can see that one project is running. If I drill into this deployment, to shut this down, I simply have to select the project and click stop. What's happening behind the scenes is the Kubernetes operator is tearing down that project and freeing up those resources. This allows now our administrators to basically be more efficient about the resources they do have and free up those that are not being used. So that really wraps up and gives you a good overview of the way we're integrating ONNX models into an ESP project, but not just testing them, but also deploying them out to a production environment.
Great overview, Steve. It is so cool to see all the levers a user can pull to enable this kind of real-time streaming analytics. I certainly
Great.
learned a lot, and I know that our users did too. And looking at the comments on the LinkedIn discussion, it seems like quite a few people out there are just planning or have it in their
Mhm.
eyesight to use Kubernetes at some point.
Right.
Do you have any advice for them? Maybe a few considerations, things to keep in mind as they're getting started on that adventure?
Yeah, and we completely understand and recognize that people are at different phases of their evolution as they move to Kubernetes in the cloud. And Kubernetes, as most of our viewers probably are, a container orchestration set of technologies. We take advantage of it because our customers are looking for very dynamic, scalable systems. That is, they want to be able to, in a hands-off manner, allow the system to scale as needed. So if your systems are such that you experience these peak demands or peak times, and you need a way to do this without a heavy administrative burden, that is, you don't need to go and manually spin up new pods or new clusters inside of, say, your containerized environment, then Kubernetes is something you probably need to look at because it provides essentially a lot of the technologies to handle auto or horizontal auto scaling that we take advantage of, also for migration and management and resource utilization. So most of our customers are going there because they want to essentially optimize the utilization of the resources they've got at their disposal in the cloud. And everybody wants to keep costs to a minimum. And this is a way to do that in the cloud.
Got it. Yeah, that makes sense. Seems like a
Yeah.
pretty powerful underpinning. Thanks
Yep.
for explaining that. Also in the comments, saw that there's a future webinar on ONNX and SAS Event Stream Processing, an Ask the Expert webinar. So everyone, take a
Mhm.
look at the comments and the LinkedIn discussion, and be sure to sign up for that one.
Yep.
Do have a couple more questions for you, Steve. So back to your demo and that interaction that you showed. What did customers do before? How did they, apply the same kind of concepts there in their
Yeah,
old
a couple
environments?
things. Sure. Yeah, and a couple things we are really helping our customers with is eliminating to a great degree the worry that most data scientists have about I've trained my model in one environment, but I want to deploy it to another. So I've trained it on NVIDIA, but I want to deploy to Intel GPUs, or even onto the edge. The edge is a very mixed bag in terms of different sets of hardware that are out there, and you've got to be considerate of and mindful of where I'm deploying these projects to. This eliminates a lot of that thought process and work required to prepare your models for those different environments to put them to use. With ONNX itself, it's designed to simplify the interchange of models from one environment to the next. So we took advantage of that and essentially just inherited those benefits that came with ONNX as a platform, as an exchange format. What it eliminates too is when you bring the ONNX into your environment, you don't have to convert it. And I mentioned some of this in the beginning. A lot of times you have to convert the model you created in one world to another language. You can leave that ONNX format intact and just deploy it into ESP, again, edge or cloud, and not have to worry about the hardware you're going to deploy it to. All of that has been taken care of, and you can focus really on solving the problem at hand.
That's fantastic. So I'm sure that you and
Yeah.
the team are working to build in even better features and functionality into SAS Event Stream Processing. What do we have to look forward to in the coming months?
Yeah, exactly. We now have CPU support, which is non-accelerated. We have NVIDIA GPU support, which accelerates inferencing. Also helps on the training side. We're really focused on the inferencing side, the runtime. But coming soon now is OpenVINO support. And OpenVINO is one of those execution providers from that ONNX runtime that lets us deploy to Intel GPUs and Intel CPUs for acceleration, which again gives data scientists even more choice for where they want to run those models in their runtime environment. So we're focusing on NVIDIA and Intel, and we're going to give you more and more options to get to those platforms easily without having to worry about recoding anything.
Excellent. Options are always
Right?
good. Thank you for
Absolutely.
joining us today, Steve. I really appreciate your time. We can't wait to follow the story and hear more about event stream
Great.
processing.
Looking forward to it. Thank you.
Sure. All right. Well, today's show just gave you a taste of the updates in SAS Viya 2021.1.3. I really appreciate the engagement here on the discussion. It looks like a lot of you are using Teams. Chris Hemmedinger, you're actually, wondering if you can turn into a chatbot on Microsoft Teams using Viya. That should be really funny. Really welcome your feedback, even beyond the show. So smash that like button. Follow the SAS Users YouTube channel to get notified about the next show coming at you in September. And until then, have a great one, guys. Thank you.